Solving systems by the Gauss-Jordan method is similar to using the matrix method. We just add in a few middle steps. So we still want to get ones along the diagonal. And for the first step, we want to get zeros along the left bottom diagonal or triangle part of the matrix. But we're okay if there are still numbers in the top right. And for step 2, that's when we're going to try to take those numbers in the top right and change those to zeros. So we start the same way by setting up the matrix using this system. So the first row is -1, 2, -4, 4. The next row is 1, 5, -2, 6. And then 3, -1, 2, -2. Okay, so there are different steps that you can take. I like to first try to get zeros here and then worry about the ones after that. So let's start by trying to turn this into a 0. The way that we're going to do that is by replacing row 2, which is this row, with row 2 plus row 1. That would be 1 plus -1, which is 0, 5 plus 2, which is 7, -2 plus -4 is -6, and then 6 plus 4 is 10. And we rewrite the other two rows. Okay, now let's try to turn the bottom left into a 0. So we want to turn this 3 into a 0. The way we could do that is by combining with row 1. So we're going to replace row 3 with row 3 plus 3 times row 1, because that would turn that first spot into a -3 added to 3 would be 0. So 3 plus 3 times -1 is 3 minus 3, which is 0. -1 plus 3 times 2 is -1 plus 6, so +5. And then 2 plus 3 times -4 is 2 plus -12, so -10. And then 2 plus 3 times 4 is -2 plus 12, so +10. Okay, that's the new row 3. And then we're rewriting the first and second rows. Okay. Next, we could leave the 7 as it is, but since -6 and 10 aren't divisible by 7, that might hurt us later. So now, just to simplify the numbers and not for any other reason, let's do row 2 minus row 3 and replace row 2 with that. This isn't necessary, it just might make the numbers smaller later. So row 2 minus row 3 would now be 0 minus 0, which is 0. 7 minus 5 is 2. -6 minus -10 is +4. And then 10 minus 10 is 0. and then replace the first and the last row. Now you don't have to do something like that, but if you ever do see an opportunity to make numbers nicer and smaller, then you can use that opportunity. So I'm going to actually do it one more time with this matrix. I notice we have 5, -10, and 10 in the last row. So we could make those numbers smaller by now taking row 3 and multiplying by 1/5. Just because these matrices are easier to work with if the numbers are nicer. So now we have -2, or -1, 2, -4, 4 in the top, 0, 2, 4, 0. And if we divide all of that last row by 5, we still have 0, and then 5 divided by 5 is 1, -10 divided by 5 is -2, 10 divided by 5 is 2. So you can see those last two steps, while they didn't give us any zeros where we wanted zeros, they did make the numbers a little bit smaller. Okay, now we do want a 0 here, so let's try to turn this 1 into a 0. The way that we could do that is by replacing row 3 with 2 row 3's minus row 2, because that would be 2 times 1 minus 2, which will give us 0 in that spot. So we already have 1 0, now we have another 0. And then 2 times row 3 would be 2 times -2 minus row 2 is -4. So that is now -8. And then 2 times 2 minus 0 is 4. And then the first two rows stay the same. And now step 1 is almost finished because we have zeros in the bottom left triangle. Now we just want to try to get ones along the diagonal. So we can do that kind of all in one step. So the first row, we need to get -1 turned into 1, so we need to just multiply the first row by -1. So that would be 1, -2, +4, -4. So just changing the signs of the first row. And then the second row, to get a 1 there, we need to divide it by 2 or multiply by 1/2. So in this same step, let's do 1/2 of row 2 to get 0, 1, 2, 0. So just multiplying all of these terms by 1/2. And then to get a 1 in the z column, we want to turn this -8 into a 1. So that would be multiplying row 3 by -1/8, which would give 0, 0, 1, and then -1/8 times 4 is -1/2. So since we weren't combining rows in any way in that step, that's why we could just multiply by the scalars on each row in the same step. We could have done it in 3 separate, but this is a little faster and less writing. Okay, so now step 1 is complete. We have zeros in the bottom left triangle, ones along the diagonal, numbers elsewhere. So now our goal is to complete step 2 and get zeros in the upper right part of the matrix. So the easiest way now to do this is to work from the bottom up. So that means to try to fix this row, the second row. So to do that, we could subtract the third row. So let's now replace row 2 with row 2 minus 2 row 3. And that would keep 0 and 1 because There are zeros in those spots in row 3. And then for this third column, that would be 2 minus 2 times 1, so 2 minus 2, which is 0. And then the last answer column would be 0 minus 2 times negative 1/2 is 1, so 0 plus 1 is 1. And then we rewrite the other two rows. 0, 0, 1, negative 1/2, 1, negative 2, 4, and negative 4. And we are almost done now. Now we just need to fix the first row. So third row is how we want it to look, second row is how we want it to look. Now we need the first row to be 1, 0, 0, and then a number. Let's start with this entry. We can turn that to 0 by using the 1 in the third row. So we could do row 1 minus 4 times row 3. That isn't going to affect the first two numbers. So 1, negative 2 stay. And then we have 4 minus 4 times 1. So that would be 0. And then negative 4 minus 4 times 1/2. Minus 4 times negative 1/2 would be negative 4 plus 2, so that's negative 2. And then the last two rows stay the same. Okay, last thing is to do something about this negative 2. We can use row 2 to accomplish that. So let's replace row 1 with row 1 plus 2 times row 2. The 1 would stay in the top left because we're just combining with a 0. And then the next entry is negative 2 plus 2 times 1. That's negative 2 plus 2, so 0. Third entry stays 0. And then negative 2 plus 2 times 1, again, is 0. And then rewrite the other rows. Okay, now the matrix is solved. So we can read off the solution. First column is x, so this means 1x is equal to 0. Second column is y, so this means 1y is equal to 1. Third column is z, so this means 1z is equal to negative 1/2. So the solution to this system is 0, 1, negative 1/2.